Assalamualaikum and very good evening to my panel, Encik Hairul Effendi and Dr. Mastura. First, I would like to introduce myself. My name is Muhammad Shafiq Amir bin SAMSUDIN with metric number B071710702. My supervisor is Dr. NUZAIMAH binti MUSTAFA and my co-supervisor which is Dr. NORFARIZA binti AB WAHAB. Today, I would like to present my bachelor degree project 2, which is the title is Design and Development of Water Rocket Launcher using Selective Laser Machine. For the chapter 1, which is Introduction, which is include problem statement, objective and scope of work of my project. For the introduction, the science, technology, engineering and maths discipline have been combined into integrated educational program for the past 2 decades. Rocket work by expelling hot exhaust gas from a nozzle. Such gases exert a strain on the rocket to move it forward and pushing backward. The weight of the gases propel the rocket by momentum conservation. Then, the turning process widely used in the manufacturing sector, including automotive and aerospace as a significant measure. For the problem statement of this project, which is the water rocket launcher nowadays is not relevant and is unsafe to use in school and university educational programs. Then, the leakage of the liquid propellant, which is water while waiting to launch the water bottle rocket. The water rocket launcher just had one angle to launch the rocket. For my objective, which is this project using SLS machine, to design a new water rocket launcher, to develop a water rocket launcher using SLS machine, then to test a water rocket launcher. For the work scope of my project, which is the high pressure air at the launcher and the water pressure in the bottle rocket are determined. The selective laser sintering SLS machine, which is the material polyamide, will be used to produce the water rocket launcher. The guard rail will be added to weaken the launch stability of the water rocket. For the chapter 2, which is literature review, this is my selected literature review, which is the aerodynamic concept and Newtonian physics are discussed and conducted by means of a workbook on the study and review problems. Then, safety should be number one priority when designing the water rocket launcher. As the launcher will be handling compressed air, it is important to make sure all fittings are properly rated. Then, the angle when launching the water bottle rocket is the most important, whether or not the rocket is flying high. The acceleration equation for the first type of thrust, in which the volume of air within the water supply chamber is smaller than the total volume of the container, can be extracted by consolidating the extracted equation of mass, thrust, drag, and weight. Drag force are characterized by frictional forces induced by the sliding motion between the rocket body and the surrounding fluid, and by the rocket mass resistance of the surrounding fluid. For the chapter 3, which is methodology, which is include a flowchart, Gantt chart, and experimental method, which is for my flowchart process, which is start and then literature review, making design water rocket launcher, then make a final concept of design water rocket launcher, set up SLS machine, fabrication of the project water rocket launcher, then test the water rocket launcher. If the water rocket launcher not successfully to launch the water rocket, will modify the water rocket launcher, and if the water rocket launcher is successfully to launch, then finishing the water rocket launcher project. This is my Gantt chart for PSM2. This is a material and equipment that has been used in this water rocket launcher project. Polyamide has been used as the material of the water rocket launcher project. The selective machine sintering machine has been used to produce the water rocket launcher. SLS is a method for sintering and construction of the powder-filled particles heated by a CO2 laser beam. Thermal imbalance of the SLS component are found inside the building chamber during the sintering process. Okay, for the methodology, which is all sparks are cooled, the build chamber was removed from the SLS machine and transfer it to the next station, which is to break the powder block manually with hand. Then clean the block with sandblasting, which is to remove the powder that's still in the hole of the water rocket launcher project. For the chapter 4, which is result and discussion. For the result and discussion, for the launcher assembly base, which is this launcher assembly base is more stable, and the installation of a support frame and a horizontal adjustment was made that suggested mounting of a support system, and the starting pad board and the angle could be adjusted afterwards. For the pressure connector house, which is pressure assembly, required a pressure source, a pressure tube and a connector. Pressure supply that can be take the form of a foot pump, communicate fluently through a connecting component with a duct or conduct structure on the bottom of the water rocket launcher to air supply. For the nozzle connector, which is the dust size in rocket, is measured in the dust with the smaller internal diameter throat. Then, in addition, the nozzle connector are used to supply the air and keep the rocket down before launch the water rocket launcher. For the next result and discussion is water fill level testing. A water rocket launcher is a rocket type that uses water and air as energy sources. The bottle is water filled, and then the bottle is then at pressure before launch the water bottle rocket. In this test, the volume of water necessary for the longest flight time in a water rocket showed that the 40% water rocket was flying the longest flight time. The purpose of this test was to research the volume of water necessary for the longest flight time in the water rocket. The entire experiment used the same air pressure and adjusted just the volume of water. All other experimental conditions were present in the same way. For the 40%, which is average time second, which is 4.51 seconds. For the chapter 5, which is conclusion and recommendation. For the conclusion of this water rocket launcher project, which is the priority of this water rocket launcher project, is the safety, which is this design is more safety to use in school and university educational programs, which is STEM program. The use of the SLS machine of making water rocket launcher will enable engineering to enter many STEM water rocket launcher activities largely in the field. Then, to travel the fastest horizontal distance, the most important component is the amount of air supply and the water which is to produce the pressure on the water bottle rocket launcher. For the recommendation of this project, is validate the study using a different method of large testing, then requiring structural analysis on the water rocket to determine a maximum pressure. Then, to make the water rocket launcher more safety, to further study of the variable affecting maximum flight is needed. If you have any question, you can ask me. That's all from me. Thank you.